horizontal ellipses, so something that looks like this, right? So it's stretched horizontally the long way, okay? Then it's going to be this equation right here. X minus h quantity squared over a squared plus y minus k squared, quantity squared, over b squared equals 1. Okay, so if you notice, because it stretches the long way horizontally, this is going to be called your major axis. While it's not stretched quite as far vertically, that makes this our minor axis, okay? For vertical ellipses, like the second picture shows, it's pretty much the same equation, but your A and B values switch places, right? Because here, A was on your major axis, you need it to stay on your major axis. But now your major axis runs vertically because now your ellipses is stretched the long way, right? So, that being said, clearly, the line with A, right, these points are containing minus A or plus A, right? And then on this graph, this contains our plus A and our minus A. A must be the biggest out of A, B, and C, right? Because they're the furthest away from the vertex. So, that being said, keep in mind that no matter what, A is going to have to be the biggest. Right? So if they give you an equation and you're trying to figure out which denominator is A and which one's B, A should be the bigger one, okay? That'll also help you determine which one it is, because if A is under Y, you know you have a vertical, but if A is under X, you know you've got horizontal, okay? So this kind of uses what we know as like a tag-on to sort of Pythagorean theorem, but we're finding the difference here, right? Because A is here and C comes from your focus, which is inside, so the difference between here, okay? So we are told that C squared is equal to the difference of A squared and B squared. Remember, A, we said, should always be the biggest one, right? And we don't want a negative distance, so it'll be A squared minus B squared to ensure that we get a positive answer when we subtract. Okay? Same thing for our vertical ellipse. C squared is equal to A squared minus B squared. But now my A will be on my vertical axis while B would be on the horizontal if we're talking vertical. So don't forget that A must be the biggest. All right. So, on example number 1, they want us to find the following pieces. It says to find the center, vertices, the foci. We are going to have 2 focus, right? That's why they use the plural form, because it comes this way, we have a focus here. It comes this way, we have a focus here. All right, so we're going to have 2 of them. All right. Now remember, we don't know, if we can't see the picture, whether it runs vertically or horizontally, but we do know that A is supposed to be the biggest, and that's what's going to tell us if it runs vertically or horizontally. So clearly, 100 is the bigger one, right? And it's under Y. So when A is under Y, that was when we had a vertical ellipses, right? So we know that this is going to be vertical. Now remember, this is A squared under here, right? And this is B squared under here. Okay, well, if you look back up at the 2 pictures that they drew for us, they used just A, like H minus A, or K plus B, or whatever it may be, right? So I don't just need A squared and B squared, I need the actual value of A and the actual value of B. So if A squared is 100, what is A? Right. And if B squared is 36, B must be 6. Right. And according to our rule up here, C squared is equal to A squared minus B squared, which in this case would be 100 minus 36, right? So c squared equals 64. So what must c be then? 8. Okay. Now, whenever we're trying to determine our center, our vertices, and where our various focus are found, if you'll look up here, just like yesterday, H and K are found with X and Y, right? So that should tell me if I shifted off the center any. Well, here, did we shift left, right, or up or down any in this equation? So my center must be at 0, 0. Okay. Now we said that this one had to be vertical because a squared was under the y, right? So that means we're going to reference this picture right here, this second one. This is the one we're looking at. Okay, to figure out how far it was from our center right here to this point, it says it's at h plus b, comma k. Okay, well, our h was 0, we said, right? And what did we say our b value was? 6. Okay, so that's going to shift it over 6, right? And then we said we didn't go up or down any. So I'm going to have a point over here at positive 6. And then apparently we would have one the other direction the same amount, right? Because it says that point is at at x minus h. H minus b. So we have vertices at those 2 points, which were at plus and minus 6, right? So I'm going to list those two. Okay. Our next vertices, the ones on the major axis, so this one up here and this one down here, says that what we're going to do there is we're going to add and subtract the value of a to the k value. Well, again, our k was 0, but what was our a value? 10. So these are going to be at positive 10 and negative 10. So we've got 2 more vertices at positive and negative 10, to the y value. There we go. All right. And then the only other thing that we're supposed to find is the foci. So like our multiple focus. Remember, those are found on the major axis, right? So those are only found here and here. And it says that you are going to add or subtract your C value to your K. And our C value was 8, right? So we're going to have one up here at positive 8, one down here at negative 8. So this would be the points 0 and positive negative 8. Okay, so if I were to draw this ellipse, I'm just going to connect the points that we came up with. Remember, the focus you don't actually draw a line to, right? Just like yesterday with our parabolas. So it just looks something like this. Okay. Again, we knew it ran vertical because we knew our A had to be the biggest, right? And so this part right here is what told us this one would run vertical. Okay, turn the page. Let's look at example 2. Okay, in this one, we don't seem to have a denominator, right? But if you look back at the 2 original equations that we were given on the front page, what did it say that they should be equal to? 1. So what could I do to turn 36 into 1? Right. So I'm going to divide this by 36, but that means I got to divide everything by 36, right? And now we can simplify these a little bit, right? So 4 and 36, this one is going to simplify to x minus 2 quantity squared over what? 9. plus, we'll have y plus 1 quantity squared over 4 equals 1, right? Okay, now remember, a has to be the biggest. So which one is a? The 9. Okay, so here is my a squared. So is this one going to be vertical or horizontal? Horizontal, because it's under the x. Okay, so a squared is 9, so a must be 3. Okay, and that means b squared is 4, so b must be 2. And remember to find c squared is equal to a squared minus b squared. So in this case, 9 minus 4, right? So c squared is equal to 5. Therefore, c is perfect. Okay. All right. So is my center at 0, 0 this time? No. What does my h and k tell us our center is?
Write 2 down there.
Okay. So remember, this is my h, this is my k. Yeah, so it's going to be at 2, -1. Okay. Now, we said this time it's going to run horizontal. So that means that my major axis is this one, right? This is my A values, okay? So how far over am I going to go from that 2 to the left and right to plot vertices? So if I move 3 places to the right, I end up at 5. So I'd have the point 5, -1 as a vertice. And if I move 3 places to the left, I'm going to end up at, okay, so I have another vertice at -1, -1. Okay? All right, my other vertices come from my b values, and this time those run vertically, right? We said b was 2, so then I'm going to have a vertice here and here, right? So where are those points at? Okay, yeah, so we'll be at 2, 1, and at -3. No, 2, 2, -3. Okay, so that's where all of our vertices will be found. All right, and then for our foci, those are on either side. This time they're going to run horizontally, right, because they go with A. And we said that we're supposed to be moving them over square root of 5, right? So left and right means that they are changing our x value. We're currently at 2, so 2 plus or minus square root of 5, -1 would be their location, right? If you don't necessarily know 2 plus or minus square root of 5 where that falls, then we're just giving a rough estimate. We know that the square root of 5 obviously is going to be a little bit more than 2 because the square root of 4 is 2, right? So I'm basically just going to move a little bit more than 2 places to the left and to the right. So you're just giving a rough estimate. You don't have to be perfect there. And then connect your vertices to make your ellipses. Okay. So now that we know how to graph them, now we're going to practice putting them in standard form. So again, we have to complete the square to do this if it's not already in those forms with our quantity squared, right? Okay, now this one is a little bit different because we're supposed to have an x squared and a y squared on one side of the equation, right? So we're going to have 2 plus blanks on one side for this one. So I am going to keep my y's together, and then I'm going to put my x's together, Okay, so I'm going to have 4y squared plus 8y. And then I'm going to put a plus blank with that. Okay? But on the same side, because in the equation we're supposed to have both of them on the same side, I'll follow that up with the same thing for the x's. So plus 3x squared minus 18x plus blank. And then I'm going to move this constant of that -5 to the other side. Okay. So now we just need to figure out what we're going to put in the blanks. Well, remember, before we can decide what goes in the blank, we need our lead coefficient to be 1, right? So for the y's, I'm going to need to take out a 4, right? So I'm going to take out a 4. That'd leave me with y squared plus 2y plus blank. And I'll close the parentheses for that one. And then I'm going to do the same thing for my x's. What am I going to take out of the x's? 3. So I'll have plus 3 parentheses x squared minus 6x plus blank. Close parentheses equals 5. Okay. Now I can decide what goes in the blank. And how do I decide what goes in the blank? We look in the middle term, half it, square it. So here, half of 2 is, and 1 squared is 1. Okay, so we added 1, right? But if I add 1 to one side, I got to do that on the other side of the equation as well, right? Don't forget that 1 has a coefficient of 4. So when I go add it over here, make sure you give that 1 a coefficient of 4. Okay? For the x's, I look at that term there in the middle. We got -6. Half of -6 is, and then -3 squared is. So I'm going to also want to add 9 over here. Again, remembering it has a coefficient of 3. So 3 times 9 is what I'll put over there. And now we just need to simplify. Okay? So over here, we had this coefficient of 4. And what does y squared plus 2y plus 1 factor into?
Y plus 1 whole squared.
Good. Okay. Plus, we'll have 3. And what does x squared minus 6x plus 9 factor into? Good. Equals over here, we got 5 plus 4 times 1, which is 4, right? Plus 3 times 9, which is 27. So what's 5 plus 4 plus 27?
36.
Good. All right. So now we're pretty close, but it's kind of like what happened on the example that we just graphed, right? We want it to equal 1. So what are we going to divide everything by? Right? All right, so we're going to end up here with our y plus 1 quantity squared over 9, plus x minus 3 quantity squared over 12 equals 1, right? Oh, I should have just gone ahead and written that in the blank. That's what we would put here in the blank for our standard form of the equation. Okay, now that it's written in standard form, we can see h and k, right? Remember, h comes from the part with x, k comes from the part with y. So where would we say the center is? Okay, so remember, h comes from the part with x. So yeah, 3, -1. All right, then it asks where our vertices would be. Well, in order to know where the vertices would be, we need to find our A and B, right? Well, which one has to be A, which one has to be B? 12 is going to be A squared, B will be 9 squared. Okay. So, if a squared is 12, then a is the square root of 12, right? Which you could simplify a little bit, right? This would simplify down to 2 square root of 3. All right? And if b squared is 9, b must be 3. All right, and then to find c squared, remember that's going to be a squared, which was 12, minus b squared, which was 9. And 12 minus 9 gives us 3. So c must be square root of 3, right? Okay, so for our vertices, for our values of a, we're going to be doing 2 square root of 3. Now, is this one going to run vertically or horizontally? Yeah, because we got the 12 with the x, so remember that means it's this first type, right? The horizontal. The big number was with the x. Okay, so that means I'm adding or subtracting a to the x value, right? Okay, well, our center was at 3, -1, so I would be adding and subtracting my a value, which is 2 square root of 3, to the 3. So it'd look like this, all right? Okay, which then means b is going to be changing the y value, right? So I'm going to add and subtract 3 from our y value of -1. Now, our b value is an actual nice number, so we can go ahead and actually do that. If I were to add 3 to -1, it would give us a point at, right? And if I were to subtract 3 from -1, we'd have a point at, right. Okay. And you guys said this one runs horizontally, meaning that the focus would be found on the horizontal axis, right? So I would add and subtract my c value from x. So it would be 3 plus or minus square root of 3. And then the y value stays at -1. Okay. So, again, they give us another one that they want us to put in standard form. So we're going to work the same way as what we just did. We're going to need to complete the square. So we put the things with the x's together plus blank, the things with the y's together plus blank, move any extras to the other side. So we could do 2x squared minus 7x plus blank, right? Plus 2y squared plus 10y plus blank equals, only thing we'd have to move over here is the 1, so it becomes a -1 on the other side, right? All right, but before we can figure out what goes in the blank, we need our coefficients to be 1. So for the x's, we're going to factor out a 2. So we'll have x squared minus 7 over 2x plus blank. Since it didn't go in evenly, we'll just leave it as a fraction there. And then what am I going to factor out for the y's? 2 as well. Okay, so then I'll have 2 parentheses y squared plus 5y plus blank equals -1, right? Okay. So for my first blank, I would half 7 over 2, right? Which would make it 7 over 4, right? And then I would square it, right? So I don't expect you to do all that in your head. So we'll leave it as -7 over 4 squared in the blank, okay? But if I'm going to add that on one side, I got to go do it on the other side as well, right? So plus, don't forget it had that coefficient of 2, -7 over 4 squared. Okay? For my other blank, this term is a 5. Half of 5 would be 5 over 2, right? So in the blank, I'm going to put 5 over 2 squared. And then I want to add the same thing over here. So 2 times 5 over 2 squared. Okay. So remember, whatever we're putting here usually is the tell for what's going to go in our parenthesis, right? So here we have a coefficient of 2, and this should factor into x minus 7 over 4 squared, right? Okay, plus, next piece also had a coefficient of 2. This one had all positive signs, so this one will be factoring into y plus 5 over 2 quantity squared. Okay, and then over here, we're going to have equals -1. Okay, if I square this term, it would become positive 49 over 16, right? But if I multiply it by 2, I could really simplify by 2, so it would become 49 over 8, right? So I'd have plus 49 over 8. Okay, and then for this one, if I square that, that becomes 25 over 4. But then I'm going to simplify it by this 2, so really just 25 over 2, right? Okay, and then has anybody already added up these ones?
Yeah, 141 over 8.
Okay, so this is 141 over 8. Okay. So then it goes on to ask us, what type of conic is this? So we ended up with the equation, I'll rewrite it down here so it's clear to see. 2 times x minus 7 over 4 quantity squared plus 2 times y plus 5 over 2 quantity squared was equal to 141 over 8. Okay, so this would get pretty messy if we tried to make that other side 1, right? So this one is actually not an ellipses. This one is a circle. How do we know it's a circle? So this is the key for how you know it's a circle. These coefficients right here have to match for it to be a circle. If the coefficients match, you're going to know you have a circle. So if you want to make note of that. And I know we have dealt at least with graphing circles when you were in geometry. If you had me, we graph circles. So, been a little while, but I'll remind you of what that formula is. You can write it over here in the margin if you'd like. But it's whatever your coefficients happen to be, right? So I'm not even going to put a number there because your coefficient could be 1, 2, 7, 15, right? But it does look, a lot like your ellipse. So it would be x minus h quantity squared plus y minus k quantity squared. But here, instead of equaling 1 every single time, it equals r squared. R stands for your radius of your circle, okay? So, they asked, what kind of conic is this? Well, we're saying it is a circle, right? They also asked where its center would be. Okay, well, remember, the center comes from your H and your K, right? So where would the center be for this one? -7/4, -5/2, perfect. And then the last thing they ask is what the radius would be. Okay, well, remember, I just gave you the equation over here, and we said that what it equals is r squared. So this is r squared, right? So how would I find r? Right. Okay, so my radius is just the square root of 141 over 8. If that actually simplified, like if there was a square root of 141, then we would simplify, but we can't do that. All right. Okay, we got 2 examples on the back. So let's flip it over and look at those. It says, find the equation for the ellipse where they give us the center, the foci, and that it has a major axis length of 12. All right, so let's go ahead and plot the points they gave us. So we've got a center at 0, 0, foci at 5, 0, and negative 5, 0. Okay, and it says that the major axis, which is going to be the one that has the foci on it, right, has an entire length of 12. Well, if the whole thing is a length of 12, that means I went how many places in each direction? 6, right? So I'm going to have a vertice here at positive 6 and one here at negative 6. Okay, so this is definitely one that runs horizontal, right? Because all of that information, that major axis is on the x-axis. All right, so let's go ahead and write what we can for the equation here. Okay, so we've got that we know it should be x minus h, but we know that we didn't shift left or right any, so 0, right? Squared over a squared. Well, our a value, we said we went how far in each direction for a? 6. So a squared must be 36. Okay. All right. And then we should have plus y minus k. Again, our center was at 0, 0. So y minus 0 squared over b squared. But do we know b? Okay, so that's what we're going to figure out. Okay, well, remember, we know that c squared equals a squared minus b squared, right? And we figured out a, and did they give us information so we could also know c? Yeah. So we figured out a was 6. We were told enough information to determine c must be 5, right? Because we went 5 in either direction. So we would have 5 squared, which is 25, is equal to a squared, which is 36, minus b squared, right? So then I could solve for b squared. I'd subtract. I'd have negative 11 equals negative b squared. So b squared equals 11. So what's b? Square root of 11. Very good. All right. So since the denominator of this fraction is b squared, it would just be 11, right? Equals 1. Did they say to graph it? Nope, just find the equation. Yeah. So this would be our equation. You could leave out the minus zeros if you prefer. Okay, last one, kind of the same thing. We have foci at 0, 0 and at 0, 8. Okay, that means that this time we are running vertical, right? And that the major axis has a length of 16. Okay, well, first I need to figure out where the center is. So where would be the center of 0 and 8? 4. So that's my center. Okay, and we said this thing has a major axis length of 16, which means I'm going how far in each direction? So if I go 8 up from 4, I would land at 12. And if I go 8 down from 4, I land at, right. Okay. So we had a center this time at 0, 4. So for the numerators, we're going to have x minus 0 quantity squared over some value plus y minus 4 quantity squared over some value should equal 1, right? Okay, so this time, since we're running vertically, that makes that my A, right? Vertical is my A. And we said we went how far for A? 8. And they gave us enough information to figure out C must be what? 4. So I'm just looking for B, just like before. So I'm going to have 4 squared, which would be 16, equals 8 squared, which is 64, minus B squared, right? So what's 16 minus 64?
Negative.
Right? So negative 48 equals negative B squared, or B squared equals 48. Therefore, B is square root of 48, right? Okay, we said we're running vertically. Bless you.
Thank you.
So that's going to put the 64 under the Y and the 48 under the X. So there's my equation. All right. Bless you.
Thank you.